All right, we are recording. We are working on gas calculations and percent composition calculations. All right, so if you guys will follow along, but I will ask for some audience participation. Our first constant, 1 mole of any gas, is home base. Is how many liters?
22.4.
22.4, you've got to know that. Again, that's at standard temperature and pressure. All right, so question number 1. I give you 3 moles. I give you 3 moles of a gas, and I want to know how many liters do I have?
3 liters, and you would have to know the mole.
Thank you. That's what I did the other time. Well, when we sort of taped but didn't tape the last lecture. How many moles are in 3 liters? So that goes back to our practice question. So I'm giving you 3 liters of gas. And to review that math from a few minutes ago, so we've got 3 liters over, that's liters, over 22.4. Liters is our ratio, and Lexi, you calculated that earlier. 0.1333. The question is how many moles of any gas. All right, so that's that math. The practice question again from the PowerPoint. Question number 2, I am giving you 0.5 liters. We're calculating moles again. So it's the same ratio, 0.5 liters over 22.4 liters. And someone crunched that number for us.
0.0223.
0.223.
0.223.
Right. That looks good. Moles. All right. So the question was how many moles are in 0.5 liters of O2 gas? O2. So it's any gas. All right. So number 3. I'm going to give you 10 liters of any gas. Math is the same setup, and that is 0.446 moles. All right, so the math on those first 3 are the same. Number 4, the math remains the same. So let's get this going. All right, so number 4, what have I been given in number 4? Number 4, I have 300 liters. 300 liters of a gas. We're going to divide that by liters per mole. And that's going to leave us with how many moles? 13.392. So that's a 3. So we're going to round that up to 4. If we followed sig digs exactly, we would only have 1 significant digit in there, but we're not going to do that. All right, let me get out Matthew's way. Matthew, are you happy with that? JM, you happy?
Yes, sir.
Isabel? Sam's always happy. All right, number 5, we've got room. I'm going to give you 20 liters now. 20 liters. And we're still asking for moles. Boy, when I made this up Thursday, or made this up in Arlington at the hospital while I was, when I found out I wasn't gonna be here Thursday. So I need to switch this up a little bit. Giving you 20 liters of nitric oxide. How many moles? There we go, liters per mole. Who's crunched that one?
0.9.
0.9, give me one more.
I'll say 0.9 because it's 0.89.
0.89, all right, I like your rationale. Moles, or 0.89. Matthew, you're just checking your answers, aren't you? Okay. Number six. Number six, we've got 150 liters of any gas, and same ratio, liters per mole. All right, what's that math? 6 point something?
6.69.
So 6.69, 6.7 moles. You guys were probably done this worksheet in like 15 minutes, weren't you? All right, number 7. Okay, finally, I mixed it up a little bit. In 7, let's get a little bit more room because this is now one of those two-parters. Two-parter here. All right, so what did I give you this time in number 7?
90 grams.
90 grams, I gave you 90 grams of CO2, 90 grams of CO2, and the question is, how many liters is that? That's a question mark, liters. So we need to solve for liters. First thing we have to do, step number 1, is figure out how many moles we have before we can do any other math. So I've got 90 grams that I gave you. Anyone remember from our lecture how many grams a mole of carbon dioxide is? Go to 44.
Yeah, 44.
44 grams per mole.
2.04.
2.0, what was your next decimal?
2.045.
45, so let's go with, we will go with 2.05 moles. That's how much we have in terms of that quantity. Now we need to convert to liters. Liters. So we multiply that by 22.4 moles per liter, liters per mole. What's that math work out to be?
45.92.
45 point, go with 9. What's our units at this point? Liters. 45.9. And, all right, so that was number 7. Number 8 is set up similarly. Number 8, what do I give you in number 8?
123.
How much?
120.
120 grams of hydrogen gas, so it's a diatomic, H2. The question again is how many moles, how many liters? All right, what does 1 mole of hydrogen gas weigh? 1 mole of hydrogen elemental weighs 1, but it's a diatomic molecule, travels as a pair. 2. So 2. So I gave you 120 grams. of hydrogen gas, which is 2 grams per mole. How many moles is that?
60.
60, Matthew, I'm sorry. In front of you. You happy with the math, Matthew? All right, 60 moles. Plug in our constant, 24 liters per mole. Wow, what's that number?
One thousand
1,344 liters. So, talking about gas, the numbers can get really, really large. All right. Now we're going to kind of go backwards in number 9. Backwards in number 9. And let's see. I'm giving you 10 liters of gas. So number 9, 10 liters of H2, hydrogen gas. Want to know how many grams? How many grams do I have? So this time I've got to figure out how many moles I have first, and then I can calculate grams. So 10 liters over 22.4 liters per mole gives me how many moles? 10 divided by 22.4? 0.45 moles of H2. I need to know how many grams I have. And H2 is how many grams per mole? 2. All right, everyone following this? Moles cancel out. What's that work out to be? 0.9. 0.9 grams. All right, everyone take a moment. Make sure this is copied down. We will have test questions. Everybody.